We continue learning workbook page 201 with one final problem involving transforming logarithmic functions. Graph g of x equals 2 log base 1/2 of x. Okay, this is a transformations problem, so we need a parent function and a transformed function. Our parent function is y equals log base 1/2 of x. Our transformed function is y equals 2 log base 1/2 of x. Let's create a graph of our parent function first. So we know that when we have a log graph, we have to use our thinking space. Half is the base, so I'm going to put 1/2 in all of these blue boxes. Blue box base. I'll start with B. All right, the exponents we get to choose, but we always choose the same ones, and they are -2, -1, 0, 1, and 2. All right, so we have to evaluate what each one of those things is equal to. We've actually done something very similar before. Half squared. Well, that's a half times a half, which is a quarter. Half to the first power is 1. Half to the, I apologize. Half to the first power is half. Anything to the first power is itself. Half to the 0 power is 1. Half to the -1. Let's do that next. A fraction raised to a negative exponent, you can flip the fraction over and change the sign of the exponent. So this is 2 to the first power, which is 2. Half to the -2, same rule. Flip over the fraction, change the sign of the exponent. This is 2 squared, which is 4. So there's our x values for this problem. Now the y values are very easy. They're simply the exponents. So -2, -1, 0, 1, 2. All right, so there we go. We have the table of points for our parent function, y equals log base 1/2 of x. All we need to do now is transform it. Let's figure out what changed between the parent equation and the transformed equation and how that will affect our points so we can create our graph. The only observed change is this 2. The 2 is multiplying outside far from x. Outside far from x means it's vertical. Multiplying means it's a stretch or shrink. Because it's vertical, it behaves the way we would expect. Greater than 1 is a stretch. So this 2 represents a vertical stretch. As a vertical, it only affects the y coordinates. And we know that the rule for a vertical stretch or shrink is that all of the y values are multiplied by the number. So y's are multiplied times 2. So if we want to get our new table of points, it's very easy. All we have to do is multiply all of our y values by 2. The x's do not change. All right, so here we go. We have 4, 2, 1, 1/2, 1/4 for all the x's. But the y's all have to get multiplied by 2. So the y's have to be multiplied by 2. So what are our new values going to be? Let's see. 2 times 2 is 4. 1 times 2 is 2. 0 times 2 is 0. -1 times 2 is -2. -2 times 2 is -4. All right, there we go. We've got all of our new values. All we have to do now is plot them. So our y's have an even mix of positives and negatives, so I'm primarily going to use quadrants 1 and 4 here. My x's go all the way out to 4. So there's 4, there's -2 and +2 on the y, and we plot our points. All right, here we go. 4, -4. Oops, I guess I need to go down a little further on the y values. All right, 4, -4, so that would be down here. 2, -2, that would be here. 1, 0, 1/2 2, so there's half on the x and then up to a height of 2. 1/4 4, so half of a half is a quarter, and that would be up here. And when we connect all of these dots together, we get our logarithmic function. Let's talk about the asymptote. The asymptote of our parent function is the y-axis, and the only way a vertical asymptote is going to be anywhere new is if somewhere in the problem there is a horizontal shift. Do we have any horizontal shifts in this problem? The answer is no. Our only transformation is a vertical stretch. So our asymptote is still sitting right here on the y-axis. It has not moved. All right, there we go. So we've graphed the function, we've plotted at least 2 points, we drew the asymptote, and now we have our final graph.